This is the third video in a series about the Golden Gate cloning DNA assembly method. In previous videos, we learned how type 2S restriction enzymes work and how to use them to enable one-pot, one-step Golden Gate cloning reactions. In this video, we are going to learn about the Golden Gate modular cloning, or MoClo, assembly standard. This is the full MoClo assembly standard. Let's go through it step by step, starting at level 0. Level 0 vectors contain standard parts. Each type of standard part contains a basic unit of genetic grammar such as a promoter, 5' untranslated region, N-terminal tag, signal or target peptide, coding sequence, C-terminal tags, 3' untranslated region, or terminator. The Golden Gate MoClo assembly standard allows these parts to be joined together in a single reaction to make a transcriptional unit. This is possible because each part is flanked by an inverted pair of BSA1 restriction enzyme recognition sequences that, when digested, release the part with a specific set of 4 base pair 5' overhangs that define its position in the transcriptional unit. We learned how this is possible in the previous video. The specific pairs of 4 base pair overhangs assigned to each type of part in the Golden Gate MoClo assembly standard are as follows. Promoter or Pro modules begin GGAG. This allows them to ligate to the plasmid in which full transcriptional units are assembled. They end TACT, which is the overhang at the start of the 5' untranslated region or 5U modules. There are 2 types of 5' untranslated region modules. 5UF modules will join to an N-terminal tag module, and 5U modules will join directly to a coding sequence module. As the end of the 5' untranslated leader defines the start of translation, these overhangs contain all or part of the ATG codon for methionine, making the join as close to seamless as possible while still retaining modularity. N-terminal tag modules start CCAT and end AATG in order to join to coding sequence or CDS modules. There are several types of coding sequence modules. 2 contain a stop codon to close the open reading frame and are followed by a GCTT overhang. Those in which the open reading frame is left open can be joined to a C-terminal tag or CT module via a TTCG overhang, of which the last 3 base pairs introduce the codon for the small amino acid serine. If desired, a second N-terminal module can be used. This will join 5U modules ending AATG or N-terminal tag modules to alternative coding sequence modules via an AGGT linker that will introduce the GGT codon for glycine into the open reading frame. Coding sequence modules with stop codons and C-terminal tag modules both join to 3' untranslated region or 3U modules, which in turn join to terminator or ter modules. Terminator modules end CGCT, allowing them to ligate to the vector in which full transcriptional units are assembled. In addition, there are modules in which multiple parts have been fused. For example, promoter and 5' untranslated region modules, 5' untranslated region and N-terminal tag modules, and 3' untranslated region and terminator modules. Level 0 standard parts or modules are assembled into complete transcriptional units in level 1 acceptors. Level 0 parts are released from level 0 backbones and cloned into level 1 acceptors via BSA1. Level 0 parts are housed in spectinomycin resistant backbones, and level 1 acceptors are carbenicillin resistant. As explained in the previous video, this difference enables the one-pot, one-step reaction. Multiple carbenicillin resistant level 1 transcription units can be assembled into a multi-gene construct in a level 2 acceptor. In the same way that level 0 standard parts are defined by specific overhangs, different level 1 acceptors also use specific overhangs to define the order of genes in the multi-gene construct. These overhangs are created when level 1 transcriptional units are released from their backbones using BPI1. Finally, high-order multigene constructs can be assembled from level 2 or level M multigene constructs. The cloning strategy for each differs slightly, but both enable the facile assembly of large numbers of transcriptional units. Level 2 and M vectors are either spectinomycin or kanamycin resistant, allowing the one-pot assembly of multiple carbenicillin-resistant level 1 modules. This completes the description of the Golden Gate modular cloning assembly standard. If you missed information on how type 2S restriction enzymes allow the one-pot, one-step assembly of parts, please watch the first 2 videos in this series. If you want to know how to use Golden Gate cloning in your own project, then please watch the next videos in the series, which will show you how to make new level 0 parts and how to assemble them into transcriptional units and multigene assemblies.